Hi everyone, my name is Nima Safayan and welcome to the session 2 of the Data Science for Risk Managers and Trading Professional series. In this session, we're going to cover a topic that I mentioned in the previous session, and that is data cleaning or data wrangling. Sometimes it's called. As I mentioned in the previous session, one of the bigger or one of the tasks that data scientists do and risk managers do, for that matter, is the whole process of staging data, and that's quite time consuming. In many ways, I find that most of my time, or 80% of my time, is spent doing some sort of data cleaning and staging my data for further analysis. There are lots of tools in R that can facilitate that, and in this session we're gonna cover some of it, and also we're gonna introduce a new data type, which has some pros and cons with respect to data frame, and and that's commonly used for a lot of time series analysis and financial time series analysis. So the tools and packages that we're going to use are dplyr, tidyr, and an XDS package. You can install them very easily, as we covered the example in the previous session. Just install package, and you can basically put in the name of that package, and if you have configured your RStudio, it should automatically install it from one of the sites that hosts R packages. So basically, going back to the first session, and as you recall, we created a session file and we saved it in our hard drive, so we can very easily now load that session. And under that, there was a series called prices, and that basically contained our Bitcoin data, and that we pre-processed for this. So one of the common themes around preparing data is effectively doing getting an initial sense of what our data looks like. For example, here I'm going to go through some of the functionalities, and you will basically see that these are some of the common functions that we have in a lot of tools such as Excel, Microsoft Excel, which does some sort of summarization of the data, grouping of the data, doing a pivot, for example, on our data, and doing some sort of filter. So kind of going through the dplyr package that we covered in the first session briefly, we're going to expand on that, and I'll show you some of the more advanced functionalities of this package. So basically, in the first line here, what I'm interested in is to basically take the Bitcoin price data, group it by year, and count the number of the observations for each year. So effectively, the group, it basically, it's an internal sort of functionality within dplyr that basically aggregates things or groups our values or our rows by certain factor, and then summarize here would basically summarize the data, and the function that and the function that we are interested in is counting the number of observations. This is very much similar to when you use pivot table in Excel and you use count function, which basically summarizes your data in terms of number of observations. And in this case, we're assigning that into a column called count. So if I run this and do a head, what you would see here is you have the year as one column and number of counts an observation. So for each year we had anywhere between 223 to 300 observations. Obviously for 2016 that's much lower. So you can basically expand on that example and apply different different functions. So you don't necessarily, you can, for example, in this case, you can apply mean as well as count to the columns that match the criteria price, meaning that any column that has a name price as part of the name of that column, you can apply these functions. So for in the cases where you have a pretty wide data frame, meaning that you have a lot of observations, for example, and you don't want to basically individually specify the column names, this is actually quite handy. So I'm gonna run this function, and we'll take a look at the result here. So there you go. So you basically calculate the mean, calculate the number of observations for each value. Obviously, these number of counts would be the same for each of these columns, because you know, we're effectively looking at the same same data across the rows, and also the mean value of the prices for each year. So kind of expanding on that, you can do that looking at, for example, summarizing data using max prices. So yeah, I mean, obviously you're going to see an NA here, which basically means that there was an NA in our data because we use price returns, which basically meant that the first row was you know, was not an integer. So that's something that you need to be careful, and generally when you basically start working with this data, you need to actually remove things such as NAs or NANs or things of that sort. So there are lots of functionalities that you can use. For example, in the next line, what I'm doing is I'm using a function called NAOmit. And as you see, I'm actually piping the data, which is a very unique dplyr functionality, which has been expanded into other packages as well. So basically, if I run that again with NAOmit function, now I see the 2016 numbers are showing up correctly. We can do, I mean, as risk managers, we like to do a lot of standard deviation calculations. So this is a standard deviation. So summarize our data by or calculate the standard deviation for each of those years, which we basically grouped using this group by function, and basically calculate the volatility for every year in our observation. The other functionality, which is very similar to filter function in Excel, is the filter in dplyr, which works very much the same way. So you can basically calculate, we can put conditional logical conditions under filter, which basically takes a certain value that you're interested in. In this case, we want to look at the observation of the price returns. These are the USD Bitcoin price returns, that the absolute value of those returns is greater than 100. So when we run this and look at the data, yeah, and we see some of the we see the price returns that are shown here. So I'm basically looking at the first few observations, and with the same, it's very similar sort of functionality as the filter. So I'm looking at the date filter. So I'm basically looking at observations in the data that the date is greater than January 1st of 2015. As you see, this is actually a new concept. You know, similar to a lot of other languages, the date functionality is actually could become quite cumbersome in R. So kind of getting a good handle of that can save you a lot of time. What I find is that date format, there are effectively two or three types of date format in R. One is time date, the other one is POSIX, CT, and LT, and then the other one is date, generic date function. In this case, I find that in many ways, like if you're not looking at very you know, almost hourly type data, it's actually easier to use just generic date functionality. For example, here I have a date string. You want to convert that to date, but you also need to provide the effectively the pattern of that date, meaning that, you know, year comes first, month, and date. And the convention is that you use this percentage sign. So in this case, what I want to do is I want to look at the dates greater than 2015, January of 2015, and arrange them using ascending format. So it's basically the functionality here is, so arrange is a dplyr function, and within that I'm basically saying negative of descending, so basically meaning ascending. So if I run this and do a head, you see the first few observations. So your date starts from 2015, January 2nd, and then if I run tail, you see the last observation, which was the July 19 data. So that's about it. I mean, in many ways, like this gives you quite a range of functionality that you can work with, and you know, filter your data, summarize it in any way you want, and arrange it and pick the columns you need. One of the other functionalities that is quite useful in R is a functionality which kind of replicates very much how the pivot works in terms of arranging your some of your parameters by column and or converting it back into more of a row format. So in this case, like if you recall the price data that we had, it basically I'm gonna just type in the format so you can basically see. So it basically had, for each row you had a year column as well as the values. But what if we want to basically, for each date, we want to see observations organized by year, meaning that we want to see the years showed up as columns here and then a value associated with that. So there is a function within R that does that quite effectively, and that function is called tidyr. In many ways, the format, which is a row-based format, is referred to as a tidy format. This is very conducive to, for example, to different sort of operations and for plotting and so on. But sometimes it doesn't lend itself to be you know, visually easy to follow. So we basically, so if you run this this chain of functions, which basically selects date, year, and price return, and arranges every all the data we have by years as column, what you're going to see is a data series that looks like this. Obviously, you know, in this case, in 2014, you can only see the data that pertains to the 2014, and then if you look at the tail of that data, the column 2016 is populated. So along the way, if there is no data, it basically puts an NA for it. This is actually quite useful in terms of when you have, for example, when you want to do historical analysis on your data and you want to see prices organized by years. You know, for example, continuous price series organized by years, and then you want to look at the min and max of what that price did over the past 5 years, for example. In order to kind of get the original data back, there is a function within TidyR called gather, and if you run this, you basically get the same original data that you had at the beginning. And then if you look at the STR, what happens here, which I want to kind of point out, and you have to be very careful with that, is sometimes the format of your data changes. Here, your year was originally in a it was defined as numeric, but here it gets converted to factor. That can cause a lot of issues sometimes, and there are legitimate reasons why factor could be useful in your analysis, but if you don't want it, it's one of those things that's quite undesired, and it can give you a lot of hard time. But it's very easy to fix that problem. So as part of this, I mean, there are different ways of doing this, but as part of it, I just want to introduce a new function called purrr. And purrr, in conjunction with dplyr package, provides a lot of functional programming capability. So for those of you who are familiar with R, this is a new way of doing lapply, or family of apply functions, without all the headaches involved. But for those of you who are not familiar with the whole concept behind functional programming, it's a way of eliminating the need for example, for loops, or things that are, when you want to loop through a data set. It basically looks at the entire data frame and applies functions to each row without you specifying it. So in this case, what I want to do is I want to apply a function which basically converts my data to a character when an observation of factor is seen. So if the data type is factor, converted to character across the entire data frame. So when I run this and look at str, as you see that the whole basically every factor in my data frame got converted to character. In fact, this is not dissimilar to if statement in Excel. It basically says conditional if a criteria is met, do something to my data. But except that this basically, you can achieve that in one line of code, and you apply it across your data frame. So kind of building on that, and building on that whole concept of functional programming, this is a bit more complicated example. So as you recall, I had two columns, which one pertained to price returns in Canadian dollars, and the other one was price return in USD. What I want to do is I want to run a linear regression and calculate the and see how my fit looks like, and calculate the R square on my linear regression, or extract R square in my linear regression. But I want to split my data by year. So effectively, as you recall, we had a column called year, which basically was extracted from the date field in the data frame. And now this is basically, I basically want to see how the relationship between Bitcoin to Canadian dollar and Bitcoin to USD changed over each year. So if I run that, you can see that the value of the R-square for each year is shown here. And in the absence of using a package like PER, you effectively had to do all of this manually, either some form of if statement and filter and separate your data frame and basically to achieve the same thing, which kind of here it has simplified the whole process. That whole function, it could be any function, you can define it. It could be a fairly large function that you can apply across your data, which are grouped by various parameters, and then you can extract useful information from them. I can run the same thing, but not looking at the absolute prices versus price returns. So yeah, I mean, in reality, in terms of price returns, there was the R-squared showed a fairly small number. Here, it's slightly higher. I mean, I don't think it's to an extent that we can make any sort of certain conclusions from this data, which was basically, I mean, I'm kind of using this to make a point and demonstrate a functionality here. But in any event, this is one of those new packages that was developed by a gentleman named Hadley Wickham, which is the mastermind behind a lot of these packages that I've shown here and in my previous presentation, and it's actually quite useful. I mean, it makes applying functions to the data series quite effective and easy. So there's lots around PER package for me as well. Like I'm actually learning this, and I started applying this as of a few months ago. And there's lots of resources that you can look at, and I've provided the link here in this slide. Another data type that I want to introduce here is a data type called XDS. It's a time series data type, and in many ways it makes a lot of functions much easier to use. And these are the functions that are mainly financial sort of functions and econometric functions. The cons, I think the big con is it does not work with data frames, and a lot of other useful packages work with data frames. So, in order to kind of get the best of both worlds, you can always convert between the two data types, and depending on the functionality, use them. And there are different ways of obviously doing the conversion, but what I found that actually made my life much easier is a setup that I'm going to show to you. So, for example, first we load the XDS package. We look at our original prices, which is prices in a data frame format. And if you look at it, it basically shows data frame, number of observations, and columns. So in this case, what I want to do is I want to basically take my entire data frame, remove the first column, which was the date column, and order my data with the first column, which was the date column, and assign it as date. So that way, what XDS does is, rather than indexing my data in terms of numeric 1 to n, what it does is indexes my data using the date as an index. So if I run that function and look at my data, now you see the data format has changed, and basically the index or my data is organized by date rather than numeric index. So now you can basically look at the data. You don't see a whole lot of change except that that date column is gone, but the date is shown as as the outer edge of the matrix or the data structure. So one of the functionalities that the XDS does, which makes things easier, is a diff function. So if I want to, for example, within my data frame or within my XDS structure, if I want to calculate day-on-day return, as you recall in the previous example, you had to do that within the construct of dplyr, and it was few lines of code. Here you can effectively use a function called diff. If you run the function, remove the NAs from it, what you're going to see is this is day-on-day price returns for CAD, Bitcoin, and USD Bitcoin. Then from here you can run run that linear regression. In this case, we're not going to separate them by year because that's going to be actually much more difficult. But however, if you wanted to apply a linear regression between price USD and price CAD, you can do that quite effectively as well. So basically, if you run that linear regression, you're going to get all the statistics pertaining to that function. So it basically gives you the formula, gives you the residuals, the coefficients, and also the R-square and adjusted R-square. So that's basically that effectively ends this session, and at the end, as I showed previously, you can save your data. So in this case, I saved the prices.xds data series, and I saved it under session2.r data. There are lots of good resources in terms of data wrangling. Hadley Wickham has a book called R for Data Science. It's in many ways it's a work in progress. He actually adds new chapters to it. It's a free book. You can also buy it or pre-order that when it's going to be ready. But it's also free, so you can look at the online version. So I've provided the link here. There is also a very good course on the use of R in data science. It's a course offered by Johns Hopkins University, which is offered through Coursera. It's part of a specialization of, I believe, 8 courses that you can take, and you get a certificate, or you can audit them for free. And the chapters pertaining to data wrangling and data cleaning are chapters 1 and 2. So other packages that are useful and which I'm not going to cover extensively in this course are QuantMod, time series financial data analysis. You can use it to fetch a lot of equity data from sites such as Yahoo Finance or Google Finance. TTR package, it's a technical trading and quant trading package. QuantStrat, which is a full functional blotter, and it has a quant trading system, and Performance Analytics, which is a risk management and performance package effectively. So a combination of all of that are quite useful for risk managers, and I've used them extensively over the years to do various things. So that ends the session 2 of the 5 sessions, and I hope you enjoyed the session, and you will join me for the next session, which we will cover data visualization.